Hi everybody, we're going to look at some extension binomial factorising questions here. Please only do these if you've done the other questions and you have marked your work. Perhaps show your teacher before you go on to these questions. The four examples I'm going to look at are these. I'm going to look at x squared plus 6x plus 9. I'm going to look at 2x squared plus 10x plus 12. I'm going to look at x squared minus 16. And finally, I'm going to look at minus x squared minus 7x minus 12. Don't forget you can pause the video whenever you need to, and you can ask questions whenever you need to. All right, first one, let's set it up. We need an x squared here. We need a plus 9 here. That's going to give us an x here and x here. And we're looking for two numbers that multiply together to give 9 and add together to give 6. Now this is not that tricky, this question. I'm sure you can see that the two numbers that multiply to give 9 and add to give 6 are going to be 3 and 3. So let's just check it. 3x plus 3x will give us that 6x. So we say that the question must have been x plus 3, x plus 3. So what's tricky about that? Well, nothing really. But I just wanted to point out that a better way to write that is x plus 3 squared, because they're exactly the same. So that one's not too tricky. In the next question, something weird's happening. We've got not an x squared, but a 2x squared. But the good news is that we've got a common factor of 2. 2 goes nicely into the first term, the second term, and the third term. So I can rewrite this question as 2x squared plus 5x plus 6. So I just divided each term by 2 and put that out the front. So now I'm going to take this 2 and I'm going to write it at the top here, and I'm going to factorise the rest of it. So now that I've put this 2 at the top, I can just factorise what's left in the brackets. So I'm going to have x squared here, I'm going to have plus 6 here, so I must have had an x there and an x there. Not two numbers that multiply to give 6 and add to give 5 are, did you guess it? 3 and 2. Plus 2x plus 3x, those two things add together to give us our 5x. So it's going to be x plus 2, x plus 3. So in this case, we just needed to factorise this a little bit, so take out this common factor of 2 before we started to use our boxes. Next question. Looks a bit weird. There's no something x term in the middle. But let's see how we go, just starting off as normal. So we've got x squared here, which tells us we've got x and x. We've got a minus 16 here. So we are now looking to get two numbers which multiply to give negative 16, and what they actually have to add to give is 0, because I could have rewritten this question as x squared plus no lots of x minus 16. Now the only way to get two numbers that multiply to give negative 16 and add to give 0 is to have a minus 4 and a plus 4. This is going to give us plus 4x. This will give us minus 4x. So 4x minus 4x is 0x, or just 0. So the question must have been x plus 4, x minus 4. Now just if you're interested, that question is called a difference of squares question, and the very first question was a perfect square. Just if you see those words around. Okay, the final question. Again, what's horrible about this question is this minus sign out of the front. We can get rid of that in a similar way as what we did with this question here, is to take out a common factor of minus 1. So I'm going to make this minus 1, x squared plus 7x plus 12. So when I go to write what the question must have been, I'm going to put a minus here. This is getting a bit messy up here. I'm just going to put a line across there. So our answer to this question is going to go here. So I'm going to move that minus up the top, and then I just have to factorise this thing here. So I do that by saying x squared, x times x, plus 12. I need two numbers that multiply to give 12 and add to give 7. And I hope you can see that that's going to be plus 3 and plus 4. I deliberately used one that we've used before. Plus 3x plus 4x, and those two things will add to give us our plus 7x. So our answer is going to be minus x plus 4, x plus 3. And I'm sorry that one got a little bit squashed up. So good luck with some of the extension questions on the factorising binomials page. Good luck.